Hi, everybody. Welcome to the first week of presentations. Um, I guess my role this week is really just to introduce and say hello to everybody. So we'll have the same sort of lecture format. Like we'll have lecture broken up into two separate videos. We have 7 per week, so I'll do 4 videos and then we'll have a break and then another 3. Otherwise, I think all I really have to tell you, I mean, of course, the videos are happening. There's a few marks for presentation summaries. Let's be honest, those are there to make sure you actually watch the videos. Quick summary of what you sort of learned from each presentation. Hopefully you find them useful. I mean, the whole point here is to give you a bit of a survey of, different technologies. What might you choose? What might you avoid in the future? So hopefully that's something you get out of these presentations. And then the other things, the written comparison and the demo website are due, I don't remember when, a couple weeks, whatever it says in courses. So that being said, let's go to the first group. And again, we'll go through a couple of those and then have a break. See you after the break.
All right, welcome. Today we're going to be talking to you about React. If you've never heard about React before, this is a good place to be because we're going to introduce it to you. You may wonder what React is if you've never touched it. And what it is it's essentially a free open source front-end JavaScript library for building user interfaces or UI components. It's maintained by Facebook and a community of individual developers and companies. React can be used as a base in development of single-page web applications, meaning that the page does not need to be reloaded in order to introduce new elements. To put it in plain words, React.js is a very efficient solution for developing fast and scalable front-end for web and mobile applications, although for mobile, you do need to use React Native. Its gentle learning curve also attracted a lot of developers. React.js is a lightweight view library that supports UI components. Therefore, in the model view controller, it is only responsible for the application's view layer. Facebook made React an open source in GitHub, and React has now evolved into a relatively stable tool. As the community grows fairly fast, there are now a lot of resources available for developers working with React. React was the first choice among all our options in the list for this tech eval presentation, partially because React is such a hot topic and such a hot framework, but also because half of our team members had heard about it, the other half had not, or never used it before. We have some data to support the popularity of React. React is on the list of the most popular front-end frameworks and owns a huge community. There are over 13,500 commits on GitHub and over 231,000 related questions on Stack Overflow. Additionally, the list of resources available to remedy potential problems while using React is quite extensive. There are more than 220,000 websites today that use React, and there's a lot of really big name ones. Here's a list of companies you probably have heard of who use React in their development. Netflix, Facebook, Instagram, Airbnb. All these companies are a relatively big name, and they use React because of its efficiency and its ease of use. We all know that React was created by Facebook and is still maintained by them, along with a community of ever-growing, passionate developers and companies. Nowadays, it achieves high rankings in popularity, developer satisfaction, and is one of the most wanted industry tools due to its excellent features. But one may wonder with that, how did React get started? The story starts in 2011, when Jordan Walk created Flask.js, a prototype to improve project management efficiency. This was the birth of what would later become and evolve into a full version of React. In 2012, Facebook bought Instagram, which later put pressure to decouple React from Facebook and make it open source. In 2013, Jordan Walk introduced what was currently called React, an open source material. It is the experimental stage for React. In 2014, there came some important features. 1, React developer tools. They were added as an extension to the Chrome developer tools, and they allow you to view web pages and see the React framework behind it. 2, the introduction of React Hot Loader allows React components to be live loaded without the loss of state. In 2015, React reached a relatively stable state. Several significant milestones pushed React even further into the mainstream. March 2015, React Native for iOS became open source and available on GitHub. In September 2015, React Native for Android began rolling out. In 2017, Facebook announced React Fiber, a new set of internal algorithms for rendering. There are also several iterations after 2017 of importance. But now that we have a basic knowledge of React and its evolvement, next, let's move further into some details about this amazing framework.
Okay, let's talk about React features. First, React has a component-based architecture. A React.js application is a combination of the multiple components, and each component has its own logic and can be reusable. For example, on the right here, we have filterable product table as a big component. It has search bar and product table as the children component. Product category row and product row are also nested inside the product table. We also can take any component here and reuse them anywhere else on the app. Component base make it easier to maintain and implement large scale project. React data flow is one-way data binding. When designing a React.js app, we often nest child component within the higher order parent components. One-way data binding gives us better control throughout the application. However, if you want to data flow in another direction, for example, on the picture on the right, if you want to access grant child to component information from the parent to component, we might want to use additional state management features like Redux, Flask, MobX, or Context API. The next feature I want to talk about is JSX syntax. JSX allows us to embed HTML code into JavaScript code. In the example on the right, we embed the result of a calling JavaScript function for mat name into H1 element. As we can see, JSX improves readability, and if anything goes wrong on the code, we'll get more useful and meaningful error and warning message. Moreover, it's helpful when working with the UI inside the JavaScript code. Finally, JSX also prevents injection attacks. On the example below, it's safe to embed user input in JSX. By default, React DOM accepts any values embedded in JSX before re-rendering them. It ensures that you can never inject anything that's not written in your application because everything is converted into a string before being re-rendered.
So what kind of problems does React solve? React is used to remedy slow performance due to DOM manipulation. React keeps a lightweight virtual DOM to keep track of changes after every component render. The virtual DOM is then compared after every update to identify which objects have changed. And on the real DOM, React can then exclusively update changed objects. The example on the right shows this concept in action. Using browser tools, we can see that only the clock is being updated in the DOM.
So, amongst all the different development tools that exist, why would one choose to use React? What sets it apart and what makes it useful? Well, part of what sets it apart is that it's so easy to understand. For example, at the beginning of this week, only half of our group had actually had any familiarity or even used React before. But in just that short amount of time, we managed to not only familiarize ourselves with its tools, but also become comfortable enough to give you this presentation today. React is easy because it only requires a basic knowledge of CSS, HTML, and JavaScript in order to get started. There's a very decent hands-on tutorial on the React website, which is where this code and this image came from, and there's also a separate step-by-step tutorial if that is more your speed. A lot of the reason this is so easy to understand is because React's use of components heavily improves readability. If you look on the right here, we can see a class board on the top. And this isn't the full function. It's just a small component of it. But this render square method calls another component square and passes a prop value I into it. On the bottom, you can see that square component, and it's rendering and returning this.props.value, which is the value that was passed into it by the board class. As a result, on the left-hand side, you see the board that's produced by this code, which is after board calls square 9 times, you get 0, 1, 2, 3, 4, 5, 6, 7, 8. All different squares produced individually from the board component calling 9 separate square components. So another thing that makes React useful is its emphasis on reusability. And what is reusability? Essentially, it's when one can take the same code and use it again and again to make their life easier. In this case, React uses its UI components, which can be used in several places over and over again. Passing different information called props, or short for properties from parents to children, allows this code to have different functionalities. Now, in this code chunk you see here, it's a function called button. And what this does is it produces a button, as seen on the right. Now, each of these buttons looks different and can have a different functionality as a result of the props being passed into it. You see the prop called props.type, which will change the class of the HTML element generated by this function. That means we can provide different CSS styling based on the different class names provided. We also have an onClick props.handleClick, which is a callback function. Since there's one-way binding, we can't actually pass information directly from a child component to a parent component. But what we can do is use the handleClick function, the callback function, to have the click on the child make the parent do something. And then using these tools, we can see that having just one function, button, we can produce a wide array of different buttons that look different and have different uses. Reusing is good coding practice because not only does it make it easier for you to read and understand the code, it also makes it easier to refactor your code later. But most importantly, it saves you time and budget when you can reuse existing code instead of having to rewrite everything and hard coding pieces on a case-by-case basis.
We've looked at what makes React useful. Now let's look at what makes React cool. One point is developer friendliness. With JSX combining HTML and JavaScript allows you a single file for a component. Also, React dev tools help you view component hierarchies. As you can see on the right here, we can use a variable called name and include it in our HTML code called hello name. Another major point is speed. Its virtual DOM makes the site faster by re-rendering only part of the DOM that needs to be. On the second image here, you can see that the function getGreeting will change its HTML message depending on if we know the user's name or not. Another reason is desirability. React is the most desired web framework according to the 2021 Stack Overflow developer survey. Combined with this, popularity is another point. It's easy to bring new hires up to speed, and knowledge of React is a desirable skill, as shown with the Google Trends for the past 12 months. Another reason is portability to mobile. Developers who learned React.js can also easily learn React Native for developing mobile apps.
React Native is a cross-platform front-end framework based on React. With React Native, you can build applications for iOS, Android, macOS, Windows, and the web. React Native code is written in JavaScript, then translated to native UI elements. With React Native, you can develop for multiple platforms using a single code base. React isn't perfect. Some downsides include fast development pace. React is constantly being updated, which can make it overwhelming for developers to keep up. Slow documentation. With the addition of many new features, documentation and tutorials become outdated fast. JSX as a barrier. Having to learn JSX can be a deal breaker for some.
To compensate for these shortcomings, React includes the React Dev Tools, which is a useful Chrome extension. It shows the React component hierarchy, highlights the components as they are being re-rendered, as you might have noticed from one of our previous slides, where the timer clock ticking down was being updated and it was being highlighted as it was being ticked off. The React Dev Tools can also search or filter components, and the Dev Tool also offers a profiler for evaluating performance. And now, to show the React Dev Tools in action, we have a demo for you.
In this demo, I'm going to go over a React app I made named Comment Showcase. So this app just allows you to go look at YouTube videos, as well as the comments with this big stylized font. So now I'm going to go and take a look at a React component named Search Results. So here, if I search for a video, this search results box pops up. If I go to Visual Studio, here you can see the actual component, the file for the component, and here's the JSX for the component. So here you can see that here is where we're adding each search result tile. So this is a child component of search result, and it's these. These are the search result tiles. So you can see that I'm passing bunch of props down to search result tile. So I'm passing a key, an ID, the title name, the channel name, the title, a thumbnail, as well as this callback function called set current video. So this is actually what we're using to change the YouTube video that's being played and the comments. So now if I go to search result tile, here we can see all the props that we're getting. And here is the JSX for the search result tile, where we're using in handle click, on click, handle click, it's calling this, which uses the callback function, set current video. Now going back to the browser, if I go to the components here, search result, here we can see the actual React component being shown through React DevTools. And here are all the search result tiles. And then if I click on a video, it calls that callback function. And here I'm on a different video. Play it. Got the comments. And you can also filter comments. And that's the end of our presentation. Thank you for listening.
Hello and welcome to Group 7's presentation on Django. What is Django? Django is an open source web framework based on Python. It aims to make developing websites quicker and easier by providing tools that are commonly needed for web development. It emphasizes reusability of components and the principle of don't repeat yourself. Django is a very popular framework with big companies such as Instagram, Reddit, Spotify, and Mozilla using it. So why should you use Django? Django takes a batteries included philosophy, meaning it includes most libraries and tools that are needed for almost anything a developer might want to do. It is able to deliver content in almost any format, it is able to run on any server platform, and it is easily scalable due to separation between different components. It also has built-in security features that protect against common mistakes that lead to security risks.
The Django design pattern. The common approach for software design pattern is MVC, which stands for Model View Controller. But this is not what Django employs. Django uses something similar called MVT, Model View Template. In MVT, model is the data access layer which handles data. Template is the presentation layer which handles user interface part completely. View executes the business logic and interact with the model to carry data and renders a template. Model plays a similar role in both MVC and MVT. However, View in MVC only renders data from models and does not deal with any business logic. Business logics are handled by the controller. Now let's take a look on how these two design patterns work. In MVC, user uses controller to manipulate data through model. Then model updates view, and then view renders updated web page to user. For MVT, user makes requests for a resource to the Django. Django works as a controller and checks to the available resource in URL. If URL maps, a view is called that interact with model and template. It renders a template. Django responds back to the user and sends a template as a response. Let's compare the differences between the two design patterns. MVC has control that drives both model and view. MVT has view for receiving HTTP request and returning HTTP response. Consider when you want to display some data on a web page. In MVC architecture, you have to write the code to fetch data from the database, write the presentation layer, map it with a URL, and send it to the user. But in frameworks like Django, with MVT architecture, you don't have to write any code related to fetching data from the database and mapping it with the URL. All these activities are handled by the framework itself. The only thing that you have to do is to tell the framework what data should be presented to the user. The framework will then create a view based on the data and send it to the user. The classic MVC pattern works by managing the state of an application. When a user performs an action or makes a request, an action in the controller is called. The controller then either tells model to make changes and update the view or return a view based on a model. Hence, we can say that the view is controlled by the controller and model. However, in MVT makes a slightly different approach. When user makes an HTTP request, the responding view performs a query on the model and collects the result set from the model. The view then fills the result in a template and sends it to the user. Modification in MVC is more difficult since view is coupled with model. In MVT, view is not coupled with a model. This makes MVT loosely coupled and easy to modify. The advantages for MVT is that it's less coupled, suitable for small or large-scale applications, and easy to modify. The disadvantages are the architecture can be confusing. Modification of models views should be done carefully without affecting templates.
For simple applications, Django provides a way to quickly build a working front-end app using Django HTML templates. Without the need to learn fancy front-end frameworks, Django templates can help you get a polished-looking website using only HTML, CSS, and some Python. Basically, Django templates gives the ability to write Python code in HTML files using the script tag. It allows you to use loops and if statements, import data from the database to use, and even route pages together. For something so simple to learn, it contains almost everything that you would need for web development. To illustrate how simple it is to get started, I will demonstrate how to get a simple page up and running. Create a new project in Django, and then run the server. If you see the rocket page when you run the server, that means everything is working properly. Then, create a new Django app. We will create a folder inside the main folder of the app called Templates. And then we'll make another folder with the same name of the main app. This is where we'll store all our HTML files. We'll make one called index.html to get started. Then, to link this file with the backend of the Django framework, it only requires 3 steps. First, we create a view in the views.py file, which will run whenever the page is called. This is where you can pass data to the page as well as other things, such as checking if a user is logged in. Right now we will just get it to return the HTML file. Then we have to specify the URLs in urls.py so that Django knows which view is associated with which URL. Right now we'll just link the view we just made with the default path, which is just an empty string. Finally, we will put our app in the list of installed apps in settings.py, which now if we run the server again, it should display the web page we just created. If we want to pass in data to our web page, we have to specify that in views. Right now, I will send a list with some numbers, but you can easily import models from the database and send in other data. With Django templates, you can add Python statements like for loops, if statements, etc. To do that, just enter the Python code desired with a bracket and a % surrounding the code that you wish to add in. For variables, just use 2 brackets instead of the %. And make sure that the data you wish to use are specified in views first. Routing is also made very easy in Django as well. Just create a new page following the same steps as before, of creating an HTML page, writing the render function in views, and specifying the URL patterns. Then all you have to do is provide the name of the page you specified in urls.py as the website link. As you can see, working with Django templates is very intuitive and easy to learn. However, it does lack some functionality compared to some of the major front-end frameworks available today. If you think that Django templates don't provide enough functionality for your app and would much rather use an existing front-end framework, such as React, Django makes it really easy to do so. Using the Django REST framework, it is also very easy to create REST API endpoints that your front-end apps can communicate with.
The admin interface of a website is the control panel, which can be used to set up and configure a project and manage its structure and content. Django provides a default admin interface. This reads metadata from your model to provide a quick interface where trusted users can manage your site. And this means that you don't need to write an admin interface for your project, and that can save you a lot of time during development and also makes it easier for you to test your models. The admin page is also customizable, so you can add your own models, but it is only recommended for internal data management due to the model-centric approach. Django also comes in with the user authentication system. It handles user accounts, groups, and permissions, and cookie-based user sessions. The authentication system handles both authentication, which is verifying that the user is who they claim to be, and authorization, which is telling you what the user is allowed to do. Authentication support is bundled as a Django contribute module in the Django contribute.auth, and by default, the required configuration is already included in the settings.py file. Okay, so first let's look at a Django project. If we look in the settings file, we can see that django.contribute.admin and Django contribute.auth are both included by default. And if we look in the URLs file, we can see that there's a path to the admin page already included. And using Django, we can also create a super user. So we open the manage.py console and then use the command create super user. This will ask for a username, an address, and a password. Okay, so once we do that, we can run and launch the admin site. And here it takes us to the admin login page, and we can log in. So once we have the admin page, we can see the authentication and authorization section. And we can also add models to the page if we have any. So to do this, we just open the admin.py file and then import the models and then register them. So So first we import them and then we register them. Okay, so once we have that, we can just refresh the page and the model should show up on the admin page. So if we look around the page, we can see that we have groups. And here we can add like multiple people to a group and they all have the same permissions. So we can choose any permission that we want, and this is good for larger projects. So for example, we can add the add group permission. And we have the same thing with users. We can see all the users, we can add different users, and we can also delete users here, and also search for them. And yeah, when we look at each user, we can edit any information about them, we can change their permissions, and we also can see the password hashing system over here, so that's good for security purposes. And we can also look at some of the content. We can look at the questions that we just added from one of our models, and we can add different questions or delete content. Yeah, and at the top bar, we can also see we can view the site and we can also change our password.
Developers will often make mistakes that cause security issues. Django has many built-in features to help avoid these common mistakes. By default, Django provides protection against many common security holes. This includes vulnerabilities such as cross-site scripting, cross-site request forgery, SQL injection, and clickjacking. The default configuration for these protection methods are documented on Django's website and even provide guides on how to customize them to fit the needs of a developer. Django also constantly releases patches for new security issues, and these are also documented on their website.
Okay, so I'll be talking about the optimization side of things for Django. Obviously, one of the most important things for optimizing a web application is just going to be caching. On the client side of things, there's obviously just kind of standard client-side caching. But Django also has a feature that they call conditional view processing, which allows you to actually interrupt a template or view being rendered if the e-tag or last modified header imply that the entity is unchanged. So you actually don't have to render the entire, you can just exit rendering the page early if you can. There's also server-side caching or view caching, which is just caching a version of a dynamic web page or even just part of a web page for Django. So if there's like a part of your website that is particularly costly to render or calculate, you can just choose to select that to be cached, or you can cache the whole website, whatever you want. And yeah, that's just built in. There's options to cache to a database, cache to a file system, or in-memory caching. So that's quite nice, just all built in. There's some other optimizations. You can replace the default template language if you want. There's session caching and a bunch of other stuff I don't really understand, so I'm just going to talk about the debug toolbar, because that to me was the most exciting thing I saw or ran into when I was working with Django. And it basically tracks all the useful things, I guess, in terms of tracking performance on a web page. So I'll just switch over to that real quick. All right, so here we are. This is the administration page of the tutorial website that they have you build. But with the Django debug toolbar installed, all you have to do is click on this tab and it'll have tons and tons of debug information for you, all the information you could want. Settings, headers, and yeah, it's just all right here out of the box. I think my favorite is the SQL queries that were made for the request. It's got a little timeline, it's got how long the query took to execute, and then you can look up information about the query itself, you know, what the exact query was, how long it took. Static files that were used, templates that were rendered, cache calls, yeah, just right out of the box. So
let's look at some pros and cons. Django is good at handling projects with volumes of text content, media files, and heavy traffic. It also has computational capabilities that make it an ideal platform for machine learning apps. It is compatible with some really powerful machine learning libraries like PyTorch and NumPy. And lastly, it has excellent support for external libraries and packages. Now let's look at some cons. Django comes with a lot of code that requires processing and time, so it is less suitable for projects that only require a few features or requirements. Also, Django has certain set of files and predefined variables that programmers need to learn before creating any project, so developers cannot use their own file structure. Thank you for listening.
All right, so let's get started. So my name is Dev. I am the first speaker from CMPT 470's Group 12. My compatriots are Mandeepa, Aki, and JP, and we'll be presenting in this order. As you can see on the lead slide, our topic is Flask. And without any further ado, let's get into it. So, outline. Our presentation's basically split into these two main sections. First, Flask at a glance. What is Flask? What is it all about? What does it do? And second, now that we understand what it does, why would you pick Flask over other frameworks that offer the same functionality? And we've broken down those points into a few subtopics.
And first, Flask at a glance. So what is Flask and what does it do? Flask is a Python-based WSGI web application framework. So essentially, this basically means that Flask is a framework that allows us to write web servers. Code written in Flask is code written server-side. Therefore, from an architectural perspective, Flask programs expect to initialize a server, define endpoints, receive requests on those endpoints, and then respond to them. So in the standard sort of full stack perspective, where you have a front end, back end, and database, Flask sits right here in the back end. Usually, we use Flask to program the back end of web-based applications. That's where Flask is most comfortable. Now, Flask servers are usually one of two flavors. Number one, serving web pages and implementing some simple business logic, or serving a REST API suite. In our first flavor, the Flask program serves web pages. And so our web server is basically responsible for responding with the relevant pages when a specific endpoint on the server is queried. Additionally, we can also add in some business logic rules with Jinja 2. And just to sort of give an example, we have two stubs right here that indicate responses to specific endpoints. So for example, right here, we're specifying that on our web server, we want to have a hello world endpoint, a hello world URL. And if a GET request is sent to this endpoint, we want to return the hello world.html file, and we want to return an access code of 200, indicating success. Similarly below, we can also see that if there's a misfire and the user encounters a 404 error, we want to serve the 404 HTML file and return an error code of 404. In the other so usually these types of Flask programs, we see them when there isn't a fully isolated front-end framework that actually handles the rendering of the pages. So in these instances, Flask is more involved in the sort of views aspect of the web application, as well as the model and the controller. So we don't have an isolated, let's say, React front end or a more involved front end. Flask is actually playing more of a full stack sort of role. Now, the other flavor of Flask servers is the REST API suite. So when a Flask server is implementing a REST API suite, it's responsible only for business logic and brokering access to the DB. So endpoints are mapped to resource classes, and the methods of those classes define JSON payload responses for different kinds of requests. So those could be GET requests, POST requests, PUT requests, what have you. Then we have an example down here. So here we have our user class, and this class corresponds to this endpoint up here. And so the method, the GET method, basically defines the response that this endpoint will have if it receives a GET request. And as in our demo here, we can see that there is some logic being involved as well. So if the user that's being queried for through our user model doesn't exist, then we respond with a JSON payload that indicates that fact. So you've got a message, user doesn't exist, and we throw a 400 saying bad request. Otherwise, if the user does exist, then we respond with the user details and a success code of 200. Now, usually we see this sort of functionality, so sending JSON payloads backwards and forwards, when there is a completely separate, robust React, or actually any front-end framework, to be honest, framework that is responsible for serving and rendering the pages themselves. So Flask can kind of just focus on what it does best and do the controller and model side, and it leaves the view completely up to the front-end server. And so there's that strong split between the stack. So those are the two ways we usually see Flask implemented in the field, and that's what Flask does. Now that we know that, why would you use Flask? What is it that Flask offers that maybe, say, Django doesn't? Well, first and foremost, Flask is super flexible. Flask is a micro framework, and that basically means that first and foremost, it's lightweight. Flask has only two big dependencies right out of the box: Workzoid for WSGI functionality and Jinja 2 for templating. And the philosophy behind this is that instead of forcing upon the user to use specific design patterns, a specific ORM, a specific DB software, you name it, through mandatory dependencies, Flask basically just goes, pick whatever you want. And whatever you choose to use, I've got an extension to support it as if it were part of my main code base anyway. And just to demonstrate, there are over 990 available extensions that Flask supports. So it is very much oriented towards using extensions to allow other libraries than encoding mandatory dependencies in its own source code. And this quote online actually captures it pretty well. If your application was a meal, Flask isn't even the meat and potatoes. It's the plate and fork. It is the set of utensils that allows you to build whatever kind of web server you want in whatever way you want. Nothing is enforced. It just allows you to build things however you see fit. And with that, I will pass the torch on to Mandeepa. She'll lead us into, I believe it's support is the next topic. And yeah.
Next, we are going to look into support provided by Flask for developers. First of all, Python is a very popular and powerful language with a big community that has been around for a long time. Many great companies such as Google use it for their projects, and the number of people using it for web development is still increasing. Its popularity comes from excellent documentation and ease of use. Starting from Flask installation guide to deployment of a simple working application can be found at Flask documentation by going to this website shown below. The language used here is simple and is explained with lots of examples, making it easy and ideal for beginners to understand. Flask also has a great community documentation where developers can collaborate and seek help for solutions from other experienced community members. One example of these communities can be seen here in this slide. There are about 500 posts and a discussion board for members to post their questions. Other than that, there are thousands of YouTube tutorials where step-by-step demonstration for web development with Flask can be found very easily. Next up, we're going to discuss some features of Flask. First feature is simplicity and user-friendliness. Flask allows you to have a web application running with very few steps and nearly no setup. This framework simplicity and strong control over what you want in your application have made it one of the most used web development frameworks. It is simple, flexible, and has a modular nature, leading to an enjoyable development experience. Any person, be it a beginner or a Python expert, should be able to have the application up and running after following their documentation. One example is shown below, where a simple working application can be achieved in just a few lines of code and in only one single file. Another great example of Flask is its functionality. Even though it offers suggestions, Flask does not mandatorily require project outlays or other dependencies. Instead, it allows developers to choose the libraries and tools they wish to use, and additionally has various extensions available that are provided by the community. Moreover, this is an open source framework licensed under a three-clause BSD license. This means anyone can use and modify it without paying, making it even more user-friendly. Next up is our group member Aki, and he's going to discuss another feature of Flask.
As your application increases in size, you might want to divide it into more manageable modules following one of the best practice of software engineering. Flask has blueprints to satisfy this need, and a blueprint is essentially a set of operations that you register on your main and most likely the only one application object. Of course, there's nothing to prevent you from defining multiple application objects for modulation, but then you would have to manage each application object at the WSGI layer, and using blueprints saves you from that hassle. Application development using blueprints can be simplified into 2 steps. 1, implementing a blueprint, and 2, registering the blueprint to Flask application object. Blueprints can also be registered to another blueprint to inherit its prefix, error handlers, and so on. Here are some cases where the Flask documentation recommends to use blueprints. As you may have noticed, most things can be achieved using blueprints without having to juggle multiple application objects. And this makes Flask very easy to use even in production with large number of endpoints to serve. Next up, we have Swagger. If you're using Flask to implement REST API, you might want to look into using Swagger to begin with. Although Swagger isn't a part of Flask, it is commonly used in combination with Flask to complement the interface aspect of Flask when used to develop a REST API. So what is Swagger? Swagger is a specification that defines an interface for RESTful web services. The amazing part about Swagger is once you have a specification, you can generate a documentation and even some code for popular languages or frameworks. Here is an example of Swagger spec in YAML on the left and documentation generated on the right. With Swagger and Flask, your REST API development cycle becomes like this. First, you can design the API in Swagger specification in YAML or JSON format. Then, based on the specification, kickstart your backend source code by generating some code stubs. Then you can implement the actual logic for each endpoints defined in your Swagger spec. And finally, you can do some simple API calls from Swagger document that is also generated to verify that your API works. Next, we have SQL Alchemy. SQL Alchemy is another commonly used package in combination with Flask. It is an ORM for working with relational database in Python. As an ORM, it handles translating your object-oriented functions into suitable SQL actions. So ultimately, you, as a developer, don't have to know SQL to interact with database. This also makes code reusable throughout different dialects of SQL, which means you can change database system whenever you want. Moreover, SQL Alchemy allows you to keep the source code more cohesive because you don't have to mix SQL with Python. We will now have JP to continue with Jinja.
As Dev mentioned previously, one of the core dependencies of Flask is the Jinja 2 templating engine. Templating allows developers to write code that is parsed and rendered by Jinja 2 to convert that code into HTML content in the form of a view. This feature allows developers to integrate variables, conditionals, and loops directly into the HTML file. As a result, the process of writing HTML code is streamlined by simplifying the writing and maintaining of views. This is achieved through removing duplicated code, reusing templates, and placing the programming logic directly into the HTML file. Here is an example using data to populate a table. In Jinja 2, we see that there is a loop to iterate over the items and create a new table row for each one. On the right, we see its equivalent JavaScript code, which is longer and much more complicated than its template counterpart. Some of the features in Jinja 2 are that it comes built in with a set of filters, tests, and functions to further simplify the development of views. Furthermore, if developers have a specific use case that isn't covered within these built-in helpers, they're able to write their own set of filters, tests, and functions. This is done through Python code that easily integrates into Jinja 2. On a final note, the parsing API for Jinja 2 can also be extended for more flexibility along with other components of Flask. On the example on the left, we are using the built-in group by filter alongside the length function. This is similar to doing a grouping aggregate in SQL. On the other example, we write a custom divisible by n function and integrate it directly into our Flask application. In the page template, we see that it is directly usable within the template using a single line of code to register that function. Next, we are going to be discussing the security and testing considerations within Flask. Flask security features lie within two different considerations: auto-escaping and security headers. With auto-escaping, any HTML-sensitive characters, such as brackets and slashes, are automatically escaped during the rendering of the view. By doing so, any cross-site scripting vulnerabilities through Jinja 2 are prevented. Additionally, developers can set the security headers that the server attaches to the HTTP response. This allows developers to set the security level of their server as they need. Within the realm of community extensions, there are extensions such as Flask Talisman that help set and configure these security headers much more easily. On the other hand, the Flask WTF, which is based off of WT forms, is an extension that allows for more secure form validation, which can also be used to help alleviate cross-server request forgery attacks on Flask-based applications. In this example, we insert a script tag in an input and send it into the server. We see that on the left, Flask renders the script into text before it is rendered into the view. On the other hand, if we disable the auto-escaping, we see that the script is rendered as an actual HTML tag, producing a cross-site scripting vulnerability into our site. Next, we are talking about how the Flask design considerations are in relation to testing. Flask allows developers to test with any Python-based testing framework based on the developer's preference. To ensure that the application contexts of the servers are distinct between test cases, Flask has opted for an instantiable server client rather than a singular application instance. Additionally, the Flask API has classes to fake clients, requests, application context, and so on to extend the test coverage that developers need for their application. In this example, we're testing the content security policy security header on a Flask-based server. On the code block at the top, we are setting the CSP in the server route logic and returning a rendered page alongside it. Below that, we are taking a test client of our server to attempt to request the route we have written. Using PyTest as a test framework, we test the response status of that route and the CSP security header within the response. And with this, we conclude our presentation on Flask. We would like to thank you for listening and hope you have a wonderful day.
To Team 15 presentation for CMPT 470 on Vue.js. We're going to be talking about the introduction, what Vue is, when, where, why, and who should be using Vue, and exactly how do we use it with a short demo, and we'll follow up with a quick summary. So, what is Vue.js? It is one of the most popular JavaScript front-end frameworks, basically for building UI, user interfaces. It has a growth rate of 28.8%, almost 30% yearly growth since 2018. It also is an open source project for mobile and web development. And it really is focused on the Vue model and the model view model type. It also has a very shallow learning curve, which makes it useful for beginners, which we'll explore in later stages of the presentation. More technical details, it really is lightweight. It has 18 to 21 kilobytes in size that you can simply include as a simple script tag and just basically one single file. So very much lightweight. It's also declarative. It has components that generate output Y from input X, so quite straightforward. It also has stateful, so it components using data would be storing their own state and then can access and modify it later on. And it also is reactive, so if some data changes, that state changes and it will auto re-render the component. And also is device agnostic, meaning that HTML and JavaScript that's present can run pretty much on any browser, and we'll look at compatibility at the end of the presentation. So moving on, let's talk about Vue in the tech industry. Although it's very popular within the startup companies, it's also used by some tech giants, and these tech giants include Grammarly, Behance, Nintendo, GitLab, Adobe, Alibaba, and even some Airbnb campaigns. Where it would be used is mainly due to its extremely lightweight nature. With a low learning curve, it makes it a perfect tool for creating minimum viable products at startups, and also features a very rich ecosystem with official libraries and third-party plugins that are extending its use beyond just simple front-end needs. It also is a progressive framework, and you may be thinking, what is a progressive framework? So it's one of those that can be integrated into existing web applications piece by piece. So through a simple script tag, as I mentioned earlier, you can use as much or as little Vue as you want in your app. So it makes it perfect in terms of like transitions, for example, from like jQuery, for example, to integrate Vue into sort of like your modern application. And it's very easy to use. It's very powerful and extremely versatile. Sounds pretty progressive to me. So as an example, yeah, it would be a small development team that doesn't have the resources to transition the whole app to a different framework. Then the Vue would give them a way to devote as many resources as they can afford to making a gradual transition over time. In terms of scalability, it's designed to match the complexity of whatever application is being used by. So for example, it's utilizing a simple component-based design. It also provides an interface to link different plugins. And these plugins, as we will see later on, could be like a Vue router, Vuex for storing, and so on. So again, in terms of using Vue, we'll be developing a scalable project. You could be developing a project with animations and interactive elements. And it can also be used for single page and multiple page applications on the front end. And yeah, it's really great for new web developers who are just getting started with front-end development due to the simplicity of Vue. So first of all, when you develop for scale, you have Vue CLI, which is command line interface that provides you with the ability to quickly build the structure of a new project using Vue Create. And for example, it also uses Vuex store that keeps track and organizes the state of your project as it scales. So it's quite intuitive in that sense as well from state management. Again, when we could be using animations and interactions, Vue is a great place to start. It has a flexible API, and it also has built-in components based on CSS animations like transition and transition group. And I'd like to show you a winning campaign by Airbnb that was developed entirely using views. As you can see over here, right there. And you see you have videos, and they're completely interactive, changing the hand, and as well as videos on this side. Sweet. And then let's get back to it. We also have single page applications. Vue allows to streamline the process through a simple command line interface or graphical user interface commands like using run Vue Create, typical features that may include the Vuex, as I mentioned earlier, router and Vuetify. And the main idea is that you'll be able to ship a minimum viable product quickly and efficiently. And also multiple page applications. It allows you for easy integration of single page applications with server rendered multiple page applications, which basically means that you add HTML templates, insert data, and render Vue components within your existing projects for smooth transitions. And an example of such a multiple page application could be seen on the right, where you specify pages, the index pages, where the entry for that page would be, as well as what template and file names to use. as well as specifying some Webpack plugin options. As you can see, a lot of it is just explanations, and it really takes only about 8-9 lines of code to set up a multiple page application integration there. Again, for new developers, it's written in pure HTML, CSS, and JavaScript. And just like React is designed using JSX, Vue will support it as well. If you're not familiar with JSX, it's simply, it may look like simple HTML code, but it has the powerful abilities of JavaScript. So sort of like a combination of the two. Vue also has a highly praised documentation where you will be able to simply follow through a tutorial or learn from extensive documentation. So supports different types of learners. And again, the CLI, virtually anybody can configure an application to use such powerful features and plugins. And as you can see on the right, you can build these beautiful Vue user interfaces pretty much from scratch with the support and tutorials provided online. And let's talk about scalability. So plugins make it easier for developers to add the functionality they need to their apps. So for example, Vue Router will be allowing you to navigate between different components and pages. The resources will provide you methods for interacting with RESTful APIs, which is definitely useful to interact with the backend. And VueSex is a pre-built Vue component library that we have right over here. As you can see, you can play videos, you can have drop-down menus over here, lists, waiting components, on and off switches, and you don't have to repeat the work on your own right away. So all you need to do is just import those components, and that's it. So definitely quite straightforward to use. In terms of getting started, because it's a progressive framework, as we mentioned earlier, you can simply include the script tag in your HTML files, which is all you really need. The majority of third-party Vue components and libraries are additionally accessible and supported with just basically Vue.js. And you don't need to set up NPM to begin using Vue. However, when you're building large-scale applications, it's recommended to install Vue through Node Package Manager. And also, it also implies that it's helpful to use Vue for growing and new web applications, just as modifying the previous applications too. For example, you can use Vue to slowly replace jQuery in your old project and slowly integrate the new approaches in Vue. In terms of compatibility, it supports virtually every browser except for Internet Explorer version 8 and below, due to its use of certain script, ECMA script, 5 features, and then you need to be wary that may not be able to support all of the older versions of browsers, but as you can see, Chrome, Safari, Opera, Firefox are very, very much supported throughout. It also has a very powerful DevTools extension that you can install in your browser, so you can do Command F12 or just F12 on your computer to open the DevTools, and if you've installed everything correctly, you can either navigate to the View tab, and you can basically view one of the 4 things. So components is what's displayed over here. You could also view Vuex for storage and state. And you can also have a look at events and refreshing your DevTools page over here. And you can also individually access the Vue component on your web page through the context menu. So very intuitive and easy to use. We also have async components, which is yet another feature of cool feature of Vue. So it will improve load times on large applications, mainly by the fact that it will be loading components when they are needed, instead of just on an initial load, which will significantly improve loading times, page loading times for large pages. This is called lazy loading, and something is loaded only when it's needed, basically at a later stage. So again, efficiency with efficiency in mind. Now we're looking at that single file component. So it's one of the most powerful features of Vue.js is that you really extend your essential HTML elements up at the top with CSS down at the bottom and JavaScript down in the middle to encapsulate your reusable code within that specific one specific file, which makes this very easy to read. And yeah, it's encapsulation in its pure form. And also components will help you break down large projects into smaller parts, reusable pieces. And then we can extend across the entire project all of these components where you basically do not repeat yourself. You're using this principle of software engineering, so again, some software engineering in mind. Before we wrap up, I would like to show you a quick demo over here. So on the left, you can see basically the skeleton of any front-end app with a public folder with a source folder and package.json file where we have all our modules. At the same time, on the right, we have our browser being rendered. So a symbol page with hello world in view and some words and a like button. So we'll see how that changes, and we'll demonstrate sort of the structure of this little project. Just to demonstrate what it does, when you click like, we're increasing the number of likes, and then you can just keep clicking it until we get to whatever number you want. So let's see how this is set up. So as I mentioned, you have your HTML with a simple ID tag, which is important, and then we're going to be injecting our Vue.js into this ID tag from this app.vue file. So as you can see, again, template, HTML code, script, JavaScript code, and style, the CSS code. And we are simply having our divs. So one important feature of Vue is that within the template, you only should have one div at the highest level. So for example, you shouldn't have like div here because it'll be complaining about it. So simply one div over here, we inserted the logo, and then we have our component, which is hello world. Again, integrates pretty much seamlessly into HTML, and we're passing it a prop with a string hello world in view, which will then display on the right. At the bottom, we have our script tag with export default, which should be present in every Vue file. We have our components that we've been using, that we've imported right over here. And then we have our data, which technically is going to be used for like basically like state management. We have our variable likes, and we are setting it to 0. And again, we have our CSS, which we're all very familiar with from our exercises. So now we're navigating to the hello world component. Again, the beautiful feature of Vue is that you can have like child components and parent components, and you can be passing props throughout. So as you can see, we have the hello world component, which would be present in the Vue app component. And we have our division, our divs with the class names. And here we're using an h1 tag and the message that we've passed from the previous component. And this is how you access variables and props in Vue.js, just double brackets. And then we have our presentation paragraph and a button. And as you can see, when you click the button, v-on-click is a directive that launches this function like, and we can see we're just accessing the variable using this dot, and we're increasing it by 1. So we're expecting when we click the button, it's going to increase by 1. And here we have also conditional directives where we simply end up with what if statements. So if likes is greater than 0, then display this presentation has, and we get the variable value this many likes. Otherwise, v-else is another conditional directive. No one likes this presentation, and if you remember, this is what it was at all the way at the beginning of this page. So as you can see, very, very straightforward. Just your separation HTML, JavaScript, and CSS with styling, and then what we end up with is this single page application, and it can increase the number of likes to pretty much anything you want, and it's reactive, and it does exactly what is expected, and it's very user-friendly and beginner-friendly. So let's go back to our presentation. To summarize, Vue is a lightweight framework that is easy to learn and has a great documentation. It offers a wide range of flexible tools and libraries, and it follows a component-based architecture which we've seen in the demo, that allows you to build quickly while also keeping good code readability. There are a feue drawbacks that include like language barriers / restricted communities, as some plugins are developed purely in Mandarin Chinese. So other things may include like there may be too many options, you don't know where to set your eyes on, which means that you should start slow and sort of build your way into using Vue. There's also lack of financial support, which is mainly connected to it not being it being open source and not enjoying the support from large enterprises like React enjoys from Facebook or Angular enjoys from Google. And also there is limited resources in terms of not offering plugins that exist in other popular frameworks. The difference in the number of plugins available for React, for example, and Vue is in hundreds. So there's hundreds more plugins available for Vue due to Vue just being recently introduced in relatively recently in 2013. I hope this provides you with a good overview of what Vue.js does, and I'm looking forward to hearing other presentations. Thank you from Team 15.